Okay, let's have a look at logarithms then. Here's the log thing. It's basically the equivalent of indices. It's just representing numbers in a different form. You can either represent things with indices in indicial form, or equivalent, you can rearrange it to write it in logarithmic form. How are they related? Well, basically all you have to do is see this a here, swing it down, and it becomes the base of the logarithm. And once you swing that down, the y just drops down to ground level. So that's how you picture it in your mind's eye. Or, if you want to undo a logarithm and write it in indicial form, then what happens is this a swings down and hits the y in the air, and you get the x equals a to the y. So these two things are one and the same, just different ways of writing the same thing. So if we were looking at this, for example, we know that 100 is 10 squared, so swing the 10 down, and we'll know that log 10, see the log 10 of the number 100? It will equal 2. So it's the power you raise 10 to get to 100. And you raise 10 to the power 2, don't you? Here, move the 3 down. So log of base 3 of the number 9 equals, well, when that swings down to be the base of the log, the 2 drops down to ground level. So here, swing the 10 down. So log 10 of 1,000 then is equal to 3. And here, log 4 of 64 must equal 3, mustn't it? It's the power you raise 4 to get to 64, which is 3. That's what the logarithm is. So move the 10 down. Log base 10 of 1/10 equals minus 1. It's the power you raise 10 to get to 1/10. You raise 10 to the power minus 1, don't you, to get to 1/10. The quarter, so move the 2 down. Log base 2 of 1/4 equals minus 2. 2 to the minus 2 is a quarter, isn't it? So I hope you can see that you can easily transfer from logarithms to indices and from indices back to logarithms and vice versa. Okay, so with that thought in mind then, what power do you need to raise 8 to get to 64? You need to raise it squared, don't you? So swing the 8 up and hit the 2 in the 8. 8 squared is 64. 2 to the 6, unwrap that, is 64. 4 cubed, unwrap that, so 64. You should write it this way around, I suppose. Doesn't really matter, of course. 64 to the 1 is equal to 64 if you unwrap it. And then 4096 to the half. The square root of 4096 on your calculator is 64. Okay, so with those thoughts in mind, then we can start to solve problems on logs, can't we? So fairly easy things to deal with. And as long as you bear in mind the thoughts that we've just considered. So let's solve these two equations then, shall we? So let's unwrap the log, and we can solve this one. So 10 swings down, hits this in the air, so we're left with a 2x minus 1 is 10 to the 1.7. So 2x. Move the 1 over now, plus 1, and then x will equal 10 to the 1.7 plus 1 over 2. And we can tap that in the calculator, can't we? 10 to the power 1.7 plus 1. Now that's the top number, so get that equals. And then ants divided by 2. 25.56. That was the 2t. Here, to solve x, let's write the logarithm. So move this down to the base number. See it? And the x plus 1 that's in the air jumps down to ground level. And we get log 10 of 3000. This swings down to be the base number of the log, and this drops down to ground level. That's how we do logs. And move it to indicals, from indicial form to logarithmic form, or from logarithmic form back. The 10 would swing back up and hit this stuff over here in the air, wouldn't it? So move the 1 over now. Log 10 of 3000 minus 1. Let's have a look at that then. Log 10 is here, that's the log 10 button of 3000, because it's one of the default logarithms on the calculator. Minus 1. Yeah, is, what was it, 2.48 to 2dp. Okay, so that's how we solve equations then. So, we've got a little rule here, so let's have a look at this rule, and then we'll see how we use it. Let's try and prove it, and what we're going to do, it's a bit awkward, I know, to prove something, but we'll give it a little go. Don't worry if you don't see it first time through, but I want to illustrate it here. Is this true? Well, let's write it in indicial form, shall we? And see if it is. This is true, provided that if we write the xy, the object here, unwrap the log, the a swings down and hits this stuff in the air. So it'd be a to the log a of x plus log a of y, wouldn't it? So this is true, provided this is true. But if we look at the right hand side then, does it equal xy? Using properties of Lig's indices, a to the log a of x. This is equal to times you add, don't you? So this would be a to the log a of y. Because times you add the indices. And a log a of x is equal to x. And a log a of y is equal to y. So yes, it's fine. We could just check that. If you just do a log a of x, for example, equals question mark, then that swings down, so log a of x is equal to, and bring the a down, log a of question mark, which is clearly x, isn't it? So yeah, it's fine. So yeah, that's okay. Alright, so you could put an x in there. This is true because log a of x is equal to log a of x. It's just, that's what it is. If you swing that down, you get log a of x. Okay, good. Then the same holds for the symbol y, doesn't it? So we don't need to say that in addition. So there's the property then. Nicely proved by just writing it in indicial form and using the properties of indices, and noting that we can replace this by the x and the y. So we've just shown that the right hand side here is equal to xy, and if that's the case, then we can get back to that line, can't we? So let's look at that then. Log of 2 of 4 times a is log of 2 of 32, which equals question mark. What power of 2 do you need to get to 32? Well, 32 is log 2 to the 6, isn't it? So it's log 2 of 2 to the 6. So the power you need to raise 2 to get to 2 to the 6 is clearly 6, isn't it? Log 6 times you add, don't you? So 4 9s are 36. What power do you raise 6 to get to 36 is 2, isn't it? So we can just write it down. Log 4, 2 8s is 16 times you add. So we get the 16 here with the times. What power do you raise 4 to get 16 is 2. So that's clear. Now we'll move on then. Once we've done that, we've done the times you add. We'll look at the other rules for logarithms now. And what I'm going to do is create some space at the top now. I'll get rid of it all actually. And we'll write some other rules. So we've got times you add. So I'm just going to keep that. Very similar to the other rule, times you add on indices. We've just done this rule then, haven't we? I've just written all the bumps here for the next part. So this is the next rule for logarithms. Divide g minus top take bottom was indicial form. It was very akin to that with the logs. We claimed that when we have divide we minus the top take the bottom in terms of logarithms. So let's prove that then. This would hold if x over y, let's unwrap the log, would equal a swings up and hits this in the air, doesn't it? Log a of x minus log a of y. So does that hold? If this holds, then clearly this holds, because this is just dropping the a down and writing it in logarithmic form. And this is the indicial form. So here, so right hand side then, does that equal x over y, this stuff? is equal to, well, minus you divide, don't you? So you get a log a of x divided by a log a of y. And we know that a log a of x is x. We just did that in the preceding section. And a log a of y is y. Since we did it for the symbol x, let's do it for the symbol y, just in the margin here. A log a of y is equal to question mark. A to the power log a. Sorry, not on the ground. And to write that up there. Of y. Move the a down to write it in log form, and this thing in the air drops down to ground level. Log a of y equals log a of question mark. Clearly, this is y. Because these are the same, aren't they? So there's no problem with that being the value y. So that's fine. No problem at all. So this property holds. So we can use it from here on in. So minus, you divide the top over the bottom. This is log 6 over 42 over 7, which is 6. And what power do you raise 6 to get to 6? You raise it to the power 1, don't you? That's the logarithm. Here, log 2 of 5 over 80 it would be, wouldn't it? Which is log 2 of 1 over 16. 1 over 16, yeah? Which is log 2 of 2 to the minus 4. What power do you raise 2 to get to 2 to the minus 4? You raise it to the power minus 4. So that's good. So this leads us to our next property here. What happens is this little chappy here jumps down to ground level to be there. Let's just prove it in the margin here. Just shouldn't take up much room. Does this rule hold then? Can we just use this rule? Let's unwrap the log to see what it really is saying. It's saying that if this holds, then x to the y, this number, swing the a down and hit this in the air, or equal a to the y log a of x. And that's indices times, so it's power, isn't it? So you can write that as log a of x. Power times y, because you write that product run the other way. A log a of x is just equal to x. So it's x to the y, which is what it is. So it does equal that, so this holds. So now that we've proved that property, I'm just going to get rid of it. It's just unwrapping the log and seeing what was what. Let's just use it then. The 4 can jump down now. So using that rule, the 4 jumps down to ground level when it's in the power. So it's 4 log 2 of 8. And you raise 2 to the power 3 to get 8, don't you? So it's 4 times 3, which is 12. Here, plus, so you times them. Oh, but the first thing is you've got a 3 to move up first. So it's log 4 of 2 cubed, which is 8, plus log 4 of 8. Plus you times, don't you, with logs. Log 4 of 64. And you raise 4 to the power 3 to get 64. So that's 3. Next one. 2 log 6 of 4 would be log 6 of, I'm just going to, because I haven't got much, I'll just get rid of the other stuff here and do it above. That's the easiest thing to do. So I'm going to write the equals above it here. This would be log 6 of 16. 4 squared is 16. 3 cubed plus log of 6 of 3 cubed is 27. I'm tempted to write it as just 3 cubed at the moment, and I'm tempted to write this as 2 to the 4 at the moment. That's 2 to the 4, save the numbers getting too big, minus log 12, log 6 of 12. So this is log 6 of plus u times 2 to the 4 times 3 cubed, and then you've got minus log 6 of 12. So minus you divide, so it's log 6 of 2 to the 4 times 3 cubed over 12, which is, you can write as 4 times 3. So that would equal log 6 of two of the 2's will go 2 squared, and one of the 3's will go 3 squared, which you can write that as log 6 of 6 squared, can't you? 36 in other words. So There's 2.